On today's episode, OpenAI may design their own chips. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Integrated circuits, particularly microprocessors and memory, are the building blocks of almost every modern technology. Much of modern computing technology has its origins in basic general-purpose microprocessors like the venerable 8080, with code defining the application. Now, as more sophisticated needs developed in industries such as aerospace and automotive, special-purpose semiconductors evolved to handle the unique needs of industries where software simply wasn't enough. Traditional mass-market chip makers have never been interested in very expensive special-purpose devices with relatively small production runs, and as a result, a new generation of fabless IC developers have evolved rapidly in the last decade. Fabless production is a process made more complex by the Biden administration's new sanctions against the transfer of integrated circuit technology to China. For some users in industries such as automotive, circuit density and processing speed may not be critical, and there are a wide range of manufacturing options for custom chips in the 20-nanometer range. But for the rapidly evolving AI industry, very dense, very fast processors will be needed. Reuters has recently reported that ChatGPT owner OpenAI is coping with a shortage of high-performance ICs with multiple strategies, from tighter collaboration with current suppliers like Nvidia to in-house development of their own designs. OpenAI currently uses a Microsoft-built supercomputer that uses semiconductors originally designed for graphics purposes, specifically Nvidia GPUs, of which 10,000 are required to operate the OpenAI system. Reliance on Nvidia as a sole source supplier is obviously problematic, as are the high costs of the units and the considerable infrastructure and energy costs needed to run them. A new generation of AI-specific semiconductors are clearly needed, and OpenAI has expressed interest in alternate suppliers other than Nvidia, setting up an in-house design team and, interestingly, acquisition of an existing semiconductor maker. The timing for the latter option is interesting. A large amount of U.S. federal money is available through the CHIPS Act for domestic semiconductor production. And although there is a global shortage of the very specialized equipment needed to produce advanced chips in the 7-nanometer range, export restrictions on this technology to China should in the short term alleviate that problem. There may never be a better time for a deep-pocketed new technology company to take control of its hardware needs than right now. The ability of OpenAI to scale rapidly depends on semiconductor availability, and as artificial intelligence becomes ubiquitous globally, it's also a possible secondary market as a hardware supplier to other AI service providers. Fab or fabless, the artificial intelligence industry may produce the next Microsoft or Apple. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.